Hi, my name is Bryan Kim, a member of the KGSEA Math Circle, and today I'll be giving a presentation about algebra, some basic concepts you would like to know in algebra to solve AMC 8, 10, and 12 problems. And this is part 3, meaning that there's two other lectures about Algebra 1 that you should also check out. So to give a brief rundown of what the presentation will be about, I'll be mainly presenting about logarithms and trigonometry. And after going over the basic properties of each concept, we will be going over 3 different AMC problems: the 2005 AMC 10B, problem 17, 2021 fall AMC 12A, problem 9, and finally 2014 AMC 10A, problem 22. So starting off with logarithms, the basic definition of what a logarithm is the inverse function to exponentiation. So the basic form of exponential functions is b to the power c equals a, and then that can be converted to log a base b equals c. So the laws you see below are the logarithm laws, and this table on the left demonstrates how each logarithm law was derived from exponential laws. And the laws on the right are basically just properties that are unique to logarithms and that you should just memorize in order to sort of be able to apply them to AMC problems. I'll just give you guys a few seconds to look over it. Okay, and this is sort of a basic graph that sort of demonstrates another aspect of logarithmic functions. So as mentioned before, the basic form of a log function is y equals log x base a. And to sort of illustrate the two types of graphs I guess you can get from logarithmic functions, I created 2 examples: log x base 2 and log x base 0.5. And essentially, the reason why I wanted to show you guys that these 2 functions in particular is because they show how the graph of the logarithmic function that can be changed depending on the base number. So the first case is when the base number is greater than 1, in which you see that the function is an increasing function, meaning that as x increases, the y value increases as well. The domain is x is greater than 0 and less than infinity, and the range is all real numbers. The second case is when the base is between 0 and 1, in which you get a decreasing function, and the domain and range are the same as the domain and range you get when the base is greater than 1. So the first problem we're going to take a look at is problem 17 from the 2015 exam. And I'll give you guys 1 minute to sort of process the problem and sort of take a stab at it. So our problem reads: suppose that 4 to the power of a equals 5, 5 to the power of b equals 6, 6 to the power of c equals 7, and 7 to the power of d equals 8. What is a times b times c times d? So I'll give you guys 1 minute. So now 20 seconds has passed. If you're still stuck on what properties are being used to solve this problem, the basic properties that you need to know are, of course, the basic definition of logarithms and the fact that log b base a equals log b over log a. Okay, now that the 1 minute is passed, I'll go over how you should approach this problem. So with those two basic properties or definitions of logarithms, you can get that a equals log 5 base 4, which equals to log 5 over log 4. And you can repeat the same thought process for b, c, and d. So you get b equals log 6 over log 5, c equals log 7 over log 6, and d equals log 8 over log 7. So if you multiply all of those, then you get the following sort of flow to solving the problem. And because log 5, log 6, and log 7 all cancel out, you get that a times b times c times d equals log 8 over log 4. And then you can get, since log 8 is 2 to the power of 3, you can bring the 3 forward, as well as the 4, which is 2 to the power of 2. And you get a times b times c times d equals 3 over 2, which is b. The second problem we're going to go over is from the 2021 fall AMC 12A, problem 9. And I'll give you guys 3 minutes to take a stab at this problem. The problem reads, a right rectangular prism whose surface area and volume are numerically equal has edge lengths log 2, x, log x. What is x? I'll give you guys 3 minutes to take a stab at this problem. Okay, since 1 minute has elapsed, I'll show what what properties you'd like to use or how you should set up the problem. So obviously you're saying that the surface area and volume are numerically equal. So we know that the surface area of a right rectangular prism is 2 times the width times the length plus the height times the length plus the height times the width. Because you know that the edge lengths are log x base 2, log x base 3, and log x base 4, you can set up a basic equation for the surface area. And the same goes for the volume, which we know equals the height times the length times the width. And with the edges, you can get that the volume equals log x base 2 log x times log x base 3 times log x base 4. So now you still guys have 1 minute to sort of simplify this and sort of figure out what x is. Okay, now that 3 minutes has elapsed, I'll show the rest of the process you have to go through to reach the answer. Okay, so from that equation that you just saw, if you divide the volume by both sides, then you get this following equation: 2 times open parentheses 1 over log x base 4 plus 1 over log x base 3 plus 1 over log x base 2, close bracket equals 1. And from there, you can use this property that you see on the right, log b base 1 equals 1 over log a base b. If you apply that property to this equation that I just read out, then you get the equation beneath it. And then if you use the property that you see above, log a plus log b equals log a times b, then you get that 2 log 24 base x equals 1. And from there, you can get that log 576 base x equals 1. And through that, you can conclude that x equals 576, which is answer choice E. Okay, so that concludes the logarithmic section. So moving on to the trigonometric section. Trigonometry is a mathematical topic that studies the relationship between the side lengths and the angles of triangles, and it revolves around the following basic concept. So given this right triangle with lengths A, B, and C, we can basically find the value of sine A, which is A over C, or the side opposite length over the length of the hypotenuse. Cosine A equals B over C, or the side adjacent over the length of the hypotenuse, and tangent A equals A over B, which equals to, or also the side opposite over the side adjacent. And also just basic laws that you want to keep in mind for trigonometry are the law of sines and the law of cosines that you see on the right. These are some basic trigonometric identities that you would like to know whenever you come across problems that require trigonometry to solve them. Since they're all very long, I'll just give you guys a minute to look at them. That minutes passed. I'll move on to these two trigonometric identities, the double angle formula and the half angle formula. And these two formulas are very useful because first of all, a lot of us are able to figure out the basic values of sine, all the special angles like sine 30, sine 60, and sine 90, and like sine 40, sine 45. And whenever you come across angles that whose trigonometric functions you're not sure about, such as like tangent 15 or sine 15, then you can apply these formulas to sort of figure out the exact value of those trigonometric functions. So I'll give you guys another 10 seconds to familiarize yourself with these formulas. Okay, now that we're done with the identities, we'll move on to the 2014 AMC10A problem 22. And I'll just give you guys 2 minutes to sort of take a stab at this problem. Okay, 1 minute has elapsed. And since this problem is a little more challenging, I do have the basic approach that I would personally take to solve this problem using trigonometry. But obviously there's another solve. So you can use the next minute if you're stuck to sort of familiarize with my solution, or you can try to figure out a different way to go about solving the problem. Because you also don't necessarily need trigonometry to solve this problem, and you can just use basic geometry to figure out what the length of AE is. Okay, now that the 2 minutes have elapsed, I'll just briefly go over my solution. Okay, so the givens that you have here are that AB equals 20, BC equals, and BC equals 10. And also that angle CBE is 15 degrees. So we're trying to find out what AE is, and to do that, in order to do that, the first step you can take is to find the length of EC, which we would use tangent 15 degrees, which we got from the fact that CBE equals 15 degrees, which was a given. And as I mentioned before, since we don't know what tangent 15 is, we can use the half angle formula to figure out what its exact value is. So if you see my problem solved on the bottom left, you see that I applied the formula tangent theta equals sine 2 theta over 1 plus cosine 2 theta. And since we know the values of sine 30 and cosine 30, we're able to plug in the values 1/2 and root 3 over 2 respectively. And if we simplify the fraction, we are left with 2 minus root 3, which equals to EC over 10. And through that, we're able to conclude that EC equals 20 minus 10 root 3. And using that information, we're able to conclude that DE equals 10 root 3 because we know that AB equals 20, and we know that since it's a rectangle, CD should also equal 20, meaning that EC plus DE should also equal 20. And with that information, we can get that AE equals 2 times AD, which will equal to 20. So yeah, that's how you go about solving this problem. And that's it for my lecture. So thank you for watching.